Maybe I should just record the other one. All right, number 5. Oh boy. Okay.
Mason are praying for each other.
Yes.
That warms my heart.
Keep up good stuff. Wholesome.
Okay, number 5. Yeah. 2 cars traveling or 360 miles apart start driving towards each other. What kind of problem is this?
I just want to. Line problem.
Haven't we done these this year before?
Yes.
Pretty sure that one now. What did I always have you start doing with those distance problems? Arrows. So 2 cars start driving towards each other 360 miles apart. What should the picture look like?
2 arrows pointing at each other.
Okay.
Numbers.
What did listen? What did each of these arrows get? An R and a T, exactly. A rate and a time. We don't know the distance of the cars. Each of these arrows represents a distance. But they gave us some information about the rates and the times. A distance equals rate times time, right? So we are putting a rate and a time on each of these lines. Okay, it said the first thing it told us was the cars were 360 miles apart. Where do I put the 360?
On the bottom.
Okay, all the way across. I usually draw it like that. 360 miles, the whole distance. Okay, let's read on. They start driving towards each other and pass in 3 hours. They start at the same time and they meet each other in 3 hours. So where does the 3 hours go?
Time.
Whose time?
Both.
Both. So I know their times. I do not know their rates yet. So I'll just leave those R for now. Let me keep reading.
You dropped it.
The first car is going 4 miles an hour faster. What do I do with 4 miles an hour faster?
R plus 4.
Right. One car is going 4 faster than the other car. So if we call this car's rate R, we can call this car's rate R plus 4.
Very wise.
Okay, what is the relationship between the distances? Right. This distance plus this distance equals total distance. That plus that equals that. You not having fun right now?
You can distribute 3, so it's 3R plus 4. So then you can add the R's.
Second that motion. Really, you're gonna giggle on that?
No.
If you're gonna giggle about that, we have no hope. No hope.
Okay, they are definitely.
You're giggling about the word giggle. No problems. All right. 348 divided by 6. 58. Do you guys know what 58 means on this problem?
Just the R.
Miles per hour. What miles? Who's going 58?
The second one.
Okay, that's what we call the rate of this guy on the right here. What's the rate of this guy on the left? 58 plus 4,
Oh, wait.
62.
Right.
Okay, what are they asking for?
How fast are they?
How fast are each going? So we need the floor car going 58,
Don't have enough room.
and we need the faster car going R plus 4, 58 plus 4.
Why are they going so fast?
Do you not
Are they on the highway?
Yeah,
I go fast on the highway.
They're on a small highway, I guess.
They're not on a highway, they're actually in.
They're actually in my neighborhood, like
They're speeding.
The end.
Wait, what? That's not.
Okay, number 6, which I am not going to finish. Number 6, 2 speedboats. Okay, draw 2 speedboats. I might switch you and Carson. I might. Well, Carson needs to get out quick. 2 speedboats leave the dock at the same time in the opposite direction. So draw the arrows for that. 2 speedboats leave dock at the same time, opposite direction. Okay, yeah, why don't you guys try and label this as I read it. 1 travels 9 miles an hour faster than the other. 1 travels 9 miles an hour faster than the other. After 2 hours, the boats are 170 miles apart. After 2 hours, the boats are 170 miles apart. Yeah.
170?
Yes. Alright, did you guys figure it out?
Yes.
Yeah.
Okay, and then if you think you can, go ahead and write the equation. Here's the arrows. They're leaving from the same point, going in opposite directions. That's the arrows. What was the next part? 9 miles an hour faster. So one of them is going, doesn't really matter which you put it on. One of them is going r plus 9. 2 hours. They both traveled for 2 hours. And they were, at the end of the 2 hours, they were 170 miles apart. It's pretty similar to the last one, actually. Did you guys get that before I did?
They both equal.
Yep.
Okay, what's the relationship? Boat 1 distance plus boat 2 distance equals total distance.
Absolutely.
2r plus 2r plus 9 equals 170.
Rate conclusion.
Okay, I am not solving this one, nor am I going to even read what they're asking for. You guys need to do this on your own.
Is that fast for boats?
No.
I don't know what speed is. Let me see. That's a speedboat.
Is this due Monday?
I can swim that.
Yes, doing Monday.
30.
I'm pretty sure you can. Yeah.
They're asking for both boats.
You can't run that fast. Well, it won't
Do you
swim.
challenge my ability?
Yes,
Yeah.
yes we do.
How about you try to do it?
No.
Exactly. Yeah.
That's what we thought. Do you know how fast the fastest runner is?
Jesus.
Yeah.
Is he 28 miles an hour?
Yes.
Yeah, but
Oh.
he's never raced
And
against
when you,
me, though. Yeah, he
when
really
you
has.
swim, you're having to deal with the drag in the water.
Yeah, but I
So-
just you're dragging the air too.
So
You just laughed
air
at
is a
it.
lot less
Okay.
than water.
The drag.
Yeah.
yeah, exactly. You're gonna have to
Big
put it
smarter.
in a challenge.
What do you say?
Water
I don't have to deal with the drag.
He used to
What is the
drag
drag?
boat.
He's from behind.
I'm waiting for some people.
Yeah, just so you know, too many people are talking, so you can't
Okay.
understand what you're saying.
Number 7. Brittany and Hannah can paddle 12 miles upstream at the same time it takes to paddle 28 miles downstream.
Oh, so they're going.
Yeah, that's the one's a little bit different. Okay. Actually, I don't think we've seen one like this before. Did we do problems with water current?
No.
Never.
We haven't ever had-
Are you lying or not?
No, we're not.
We're not.
We haven't
Never.
ever.
The way you're saying that makes me think we actually have.
Yeah. Like never.
Okay.
I mean, to be honest, I don't remember it, but.
Instead of or wind current's the same thing. Instead of distance equals rate times
I
time,
think we did a wind current.
Shoot.
if you're going with the wind or with the water current, that's gonna add to the speed of your boat or whatever.
But then against, you subtract.
And if you're going against the current, it's gonna slow you down. Now, this is not a very accurate thing, because if you got a like 30-mile-an-hour headwind in a plane, that doesn't necessarily mean you're going 30 miles an hour slower. It's not quite how it works, but it's probably good enough to give you an idea of what's going on. That's why they make planes aerodynamic, so that the headwind doesn't slow them down as much. Anyways, so we're plugging our stuff into these two on this one. Number 7. Looks like only 7 is like this. 8's back to the other ones. So it says, going upstream, they can go 12 miles upstream. So is upstream against the current or is it with? It's against. So which of these is against the current?
Minus
This one. So I'm gonna put 12 in for this D. Okay. And then it says 28 miles downstream. Okay, that would be this D. Determine the paddling rate in still water if the stream is 2 miles an hour. So stream is 2 miles an hour. That's the current. So that would be the C. 2.
And time stays the same for all.
Okay. Now that I plugged all the information in, I'm going to erase these equations. Is that okay?
Yeah.
Get those out of there.
So do you not change T since it's the same?
Doesn't tell us anything about that. T is the same.
Yes.
So do we not need it to figure out the rate?
Let's see, what are they asking?
For the
Determine their paddling rate in still water. No, we just need a rate. Okay, I know how to do it, but I don't know how to do it simply. That's the problem.
Elimination.
So safe to say this problem was not on the test.
He throws it in just as a wing.
Just for fun.
Is it 14.6?
Divide by T. Add the lines.
Are you getting him on video?
Yeah.
Nearly.
Yeah. Okay. Yeah, it's an odd already. Let's do. Okay. I kind of failed to think of an easy way to do this, so I'm just gonna have to do it the only way that I could think of.
No.
Okay. Here's what I'm gonna do. I'm gonna divide by T because that gets rid of my T's on the right. I'm kind of curious how the book did this one. I don't really know. If you divide by T, the T's go away on the right. Now, why did I do that? Well, if I add, or yeah, I can cancel my R's out pretty easy right now. If I multiply by like -1 on the bottom or something, I can cancel my R's out when I add them together. That's why I did it. Oh, I thought of a better way. It's too late. We're too far in. I'm going to keep going.
No, we're not.
We're in too deep.
I am not racing.
Yes.
I don't want to go back.
So then we just do it.
Oh my god.
Here, just okay.
Here it was.
Okay, here's what it was.
Okay, so we just erase everything? Do that?
Don't forget the T.
Do we have to write that? I'm erasing that.
Okay, if you use distributive property over here, that's what I'll do. That'll make more sense to you guys, right?
Yeah, no.
What's this?
R
T.
T plus UT. I wish it'd be like this.
Okay, now here's why I didn't think we should go this route. Because that gets rid of the T's if we add those together, but it doesn't get rid of the RT's, and that's still two variables. How could I get rid of the RT's?
-1.
Multiply by -1. That's better. Multiply the bottom by -1. Now the RTs will go away.
So 14.
So I get 16 equals 14.
Divide by 4. 14. So we figure out the time.
Yeah.
So now we can just put that back in to figure out the rate.
Yes.
Okay.
I got the time is 4 hours.
The rate, on the other hand, is more.
The rate we'll have to plug in, or we'll have to plug in the
So-
time to find the rate.
4 plus.
If this is a 4, you can divide by 4, kind of like I did over here. Divide by 4 on both sides, you get 7 equals R plus 2. So R is 5. That was painful.
Yeah, why
Yeah.
not do all that work for like one number?
We didn't do that much. Most of the time I was just standing here trying to think of the easiest way to do it.
Yeah.
And even after I did it, I don't know if that was clear to you guys, but no, definitely not.
We have 5 minutes
We have one
left.
more and it's done.
Number 8. Okay, this is not a current problem, so don't freak out. This is the same as 5 and 6. Oh no, it is a current problem.
Oh.
Darn. Okay.
Another one.
No, let's skip it. Let's skip it. Let's do 9 and 10.
So it's giving
Wait, we're
me
not doing it?
9.
What about 9?
He said 9 and 10.
Okay, number 9.
Number 8.
Okay, this has its own set of tricks, but this one I still want to do. The sum of the digits, what's a digit?
Number.
It's like if I have the number 78, the digits are 7 and 8.
Oh.
Okay?
Oh.
What is, shh, listen. What is the value of the 7 right here?
70.
70. The value of the 8 is just 8, but the 7 is actually worth 7 tens, right? It's worth 7 times 10. Okay, anyway, keeping that in mind, the sum of the digits of a 2-digit number is 15. So it could be 78. I hope I didn't accidentally write the answer down. I did not. Thankfully, I did not write the answer down. It could have been 78, because 7 plus 8 is 15. It's not 78. I just looked at the answer. Okay,
Imagine.
so we have like a two-digit number. We'll call it AB. A stands for like the tens place. B is the ones place. They're saying the sum of those 2 digits is 15. Okay, that's sentence number 1. Sentence number 2.
Did you say sin?
Sentence. If the digits are reversed, the number formed is 9 less than the original.
So.
Okay, hold on. Shh, hold on. What is the value of this number right here? We just talked about it over here.
10 times A.
10 times A plus B. The value of this number is 10 times whatever A is plus B. They're saying if we switch the order of the numbers, like make it BA, 10 times B plus A, that this one is 7 less than this one. This one is 7 smaller than this one.
So minus 7.
Well, you could minus 7 from this side
That's
to make it this, or you could add 7 to this side to make it equal that.
It's
9.
9 less.
It was 9? Yeah, I see it now.
Thank you.
It was 9 less.
Oh my gosh, you're correct, your teacher.
That can happen even in code.
Impossible. All right.
My dad did it.
How can we simplify this right here?
I don't know. These two variables.
Okay, shh. We're gonna move all the variables to one side to make this simpler. I'm gonna minus my A's and B's over to the left. I'm gonna go ahead and rewrite this one down here.
Multiply the bottom one by negative 9.
Well, we can just multiply by positive 9, right? Because
True.
that will just get rid of our...
Are you itchy?
Shh. Hey, you're about to move. It's like the third time I've shushed you today. Okay, bottom 1 times 9. What's that, 135?
Oh boy.
Okay, 9a plus 9a is 18a. B's go away. 9 plus 135.
Why?
Because God said so.
What's a come out as?
8.
Okay, is that the answer?
No.
No. So here's our first equation. A plus b is 15. So if a is 8, what does b have to be?
7.
7. Is that the answer?
Yes.
No.
87.
87 is the answer. A was the first digit, B was the second digit.
It's 72.
So it was not 78, it was 87.
Do we have time for 10, 11, and 12?
Oh, heck yeah, we got time for 10.
You what?
Oh, we
He's joking.
What do we have? Second?
We had no time.
You say.
So what are we doing?
I'll give
Saving it for Monday?
Why don't you guys try 10 for homework?
So, should 11, 12 we do?
But no promises.
No, you don't have to do 11 and 12, just 10.
So it's just 1 through 10?
Yes.
I can't come back.
Well, actually,
Okay,
we
what?
do number 8, so technically it's not 1 to 8.